here is a circle and its equation. So all equations of circles come in the format x squared plus y squared equals r squared, where r stands for the radius. So these will be circles who have their centre at the origin. You don't have to deal with circles that aren't there, or at least that's my understanding. So let's look at a typical example. So here they're asking us to find the equation of the blue line, the tangent at point P to this circle. First of all, let's write down the equation of this circle. So we can see that it's got a radius of 6. So the equation of this circle will be x squared plus y squared equals 6 squared, which is 36. So we want to find the equation of the tangent. First of all, what we're going to need to do is we're going to need to find the equation, or at least the gradient rather, of radius. So this involves a little bit of knowledge about circle theorems. The radius here always hits the tangent at a right angle. And what we know about gradients is if they're perpendicular to each other, then it's minus and the inverse. So if we can find the gradient of the first line, the green line, then we can find the gradient of the blue line. And once we've got the gradient and a point, we can find its equation, which is what they're after. Drop this down here because P is 3 and that is 5. So in terms of the gradient of that green line, the change in the y direction is 5. Change in the x direction is 3. So that's the gradient of the green line. So that means that the blue line's gradient will be the negative and flipped version. So it'll be this. And we know that the point 3, 5 is on that line. So now we can work out the equation of that line. So we're going to use y minus y1 equals mx minus x1. So we've got y minus 5 equals minus 3 over 5 brackets x minus 3. So what happens next depends on exactly what format they're asking for the equation in. Okay, so I'm going to do it so that it ends up looking like the typical y equals mx plus c version, but there are easier versions that they might ask for you as well. So we'll expand the right hand side, so that's y minus 5 equals minus 3 over 5x plus 9 over 5, and then final step, y equals minus 3 over 5x. I've got to add 5 to both sides, and 5 in fifths would be 25. 25 and 9 is 34, so I'm going to write that as 34 over 5. But the key points here, we're finding the gradient of the radius first, and then inverting it and making it the negative form to get the gradient of the tangent, and then we could find its equation. Here's another classic style of question. So they've given us the equation of the circle. They've told us the x coordinate of P. And we've got to find out what Q is. So Q and P are both on this tangent again. So just like in the previous example, we're actually going to need to find the equation of the tangent first, then we can find out the coordinates of Q. So if we've got an equation of a circle that's x squared plus y squared equals 9, that means that the radius must equal 3. Okay, now we've been told that P has an x coordinate of 2. Sorry, that's up. We don't know what the y coordinate is, but of course we've got a link between the x and the y in the equation of the circle. So if x is 2, x squared would be 4. Let's back colours. Plus y squared equals 9. So y squared equals 9, take away 4, which is 5. So y equals the square root of 5. Not the nicest of answers perhaps, but there we go. Now we know that the other coordinate of P is root 5 here. So we can find the gradient. So the gradient of the radius is going to be change in y, which is root 5, over the change in x, which will be 2, which means that the gradient of our tangent is going to be flipped and negative. So we're minus 2 over root 5. The equation of the line that goes through P and Q is going to be y minus root 5 equals minus 2 over root 5 brackets x minus 2. We don't need to faff about rearranging this formula. We're just trying to find the coordinates of Q. And one of the coordinates of Q we can see already, and that's the y coordinate. The y coordinate must be 0 because Q is on that x-axis. So we just need to find out what x is when y is 0 in this equation. So if y is 0, we just lose the y off the front, and we're going to multiply by root 5 on both sides just to make life easier for ourselves as well. So I'm doing both of those things in one. So on the left hand side now we're going to have minus 5 equals minus 2 brackets x minus 2. Divide both sides by minus 2. We're going to have 2.5 equals x minus 2. Add 2 to both sides and we get that the x coordinate of Q is going to be 4.5, and as I've already pointed out, the y coordinate is 0. Here's another classic type of question. Blue line here, they're telling us, is a tangent to the circle with equation x squared plus y squared equals 20. And A is at 2, 4. Let's pop that on the diagram to make that clear. And the line crosses the x-axis at B. And what we know about point B is that the y coordinate of it is 0. And we will need to find the x coordinate. Now we've just been through that process in a previous example. So let's get to that point and then we'll see how that helps us to do the final bit, what they're asking for, which is working out the area of a triangle. So remember, we need to get the equation of that blue tangent line, starting by getting the gradient of the radius going up to A, and the gradient of that radius will be 4, the change y over 2, which is 2. Therefore the gradient of the tangent will be flipped and negative, so in this case that will be minus a half. So using the point A to get our equation, we'll have y minus 4 equals minus a half brackets x minus 2. Again, I'm not going to tidy this up because I just want to find that x coordinate for b. And that, so I'm going to substitute y equals 0 into this equation because b is on this line. So we'll have minus 4 equals minus a half x minus 2. Now I'm going to multiply both sides by minus 2 to get rid of that half. So that will give us 8 over here equals x minus 2. So final step, x is going to be 10. So now write on here 10 here. So having done that, now we can work out the area of the triangle OAB. So remember the formula for the area of a triangle. A half times the base times the perpendicular height. So in our case, it'll be a half times the base. So the base is OB, which we now know is 10 long. And the perpendicular height will be from A straight down, and therefore that's 4. So a half of 10 is 5 times 4 is 20, and that's the area of our triangle.